Hi everyone, welcome, and thank you for giving your time today at the AWS Cloud Container Summit. I hope you've had time to check out some of the sessions prior to this. It's an awesome lineup of content and speakers. My name is Omar Paul, and I'm an AWS product manager focused on Amazon ECR. ECR is the Elastic Container Registry, a managed registry service that makes it easy for you to store, manage, and deploy your OCI and Docker images. Today, I want to spend some time discussing ECR best practices around security for you to consider as you run container workloads in the cloud. Here's how I see this breaking down. We'll do a quick overview of our favorite registry, ECR, and talk about container security overall, and then think about ECR best practices in three categories. Throughout the session, there are links to documentation, blogs, and source code, and we'll summarize them in the end in a page. Please send me questions. Send in the questions as the session is going on, and moderators will be on hand to answer them for you. Right, before we start, I'm making some assumptions. I'm assuming that everybody in the audience understands containers, understands how an image is composed, understands how containers are built and run, and finally assume that everybody has an AWS account and runs containers in the cloud. So, okay, let's start with a short overview of ECR and container security. So what is ECR? ECR is a managed registry service. Right? We work hard to make it easy for developers to store, manage, and deploy OCI and Docker container images in the cloud. We have our own API, and we also support the familiar Docker CLI, for example, Docker push and Docker pull and the like. ECR is integrated with a whole slew of other AWS services, Amazon ECS and Amazon EKS, and AWS Fargate, so you can run your container workloads, IAM and KMS for security, key management, CloudWatch metrics and events for observability. ECR is built on S3 and uses that for image storage, so you get the durability and availability of S3 worldwide with ECR. ECR encrypts your images at rest using AES 256, as well as in transit with HTTPS. And quick call out, we've just started rolling out KMS encryption of images at rest with customer master keys, which is great news, and I think in the next few weeks or so that will be complete. This gives us high compliance workloads the comfort that they can use their own key to encrypt images at rest. Finally, ECR also integrates with AWS core competency partners for services, such as image scanning, for instance. As a core AWS service, ECR runs in every region. And I can safely say that every day, tens of thousands of container customers, including many AWS services, use us. Every week, we serve upwards of 2 billion image pulls. So if you stop to reflect on that number, that's an awful lot of images pulled. And I say all of this essentially to tell you that our job is to be able to do the undifferentiated heavy lifting in operating a container registry so you can focus on building your container applications and not have to manage that for yourself. Okay. That being said, let's talk about container security, maybe end-to-end. What is it? And we like to think of container security as securing your application lifecycle from dev through prod, right? This is very much a software supply chain concept, and a registry like ECR plays a part in it. However, as the last step before you deploy something into production, it is the final place at which you can catch vulnerability before you go live with it, right? In each pillar, right, build, deploy, and run, you have to think about security for that for that stage, right? For example, securing network access between nodes in your running clusters, that is something AWS App Mesh can help with, right? Checking for vulnerabilities in your images before you deploy in production, that's something ECR can help with. Common to security are concepts such as access controls, logs, and audits. And when you use AWS across your entire application lifecycle, you get centralized permission control with IAM, you get actionable audits with CloudTrail, you get secure key and secure management with KMS. And what that means is you have this consistent way of approaching a lot of your security strategies, which just has this core benefit to you as an AWS customer. So let's dive in a little bit into what the registry has to play in a role like this. We think about this in three parts as well. One is access control. Who can push and who can pull what resources? And here ECR and IAM work together. Second, image assurance, right? Checking for vulnerabilities in your images to assure yourself that it's safe and secure to run, doing before deploying as well as during production, right? And third, artifact trust, which is signing of artifacts, right? And here I'll talk about the in-flight Notary v2 initiative that we have going on and what that means for image signing in ECR. But common to all of these is least privileges, periodic audits, and alerts. So, for instance, start with minimal access, really, and then build on that, right? Ensure you periodically review your policies, your settings, to make sure that you don't drift away from that, because that happens because we work in such fluid environments. And three, listen for events and alerts. For example, do you fire an event or notification if a production image is deleted from your registry? You could do that. And so those are some of the things we'll talk about in these best practices in the next sessions. Let's start with user access control, which is security by managing who can push, who can pull, and on what resources, right? Best practices. Think about the first one. Think about push and pull differently. Use the Amazon EC2 container registry read-only managed policies as much as you can, and then add on push actions from there for your IAM roles and uses, right? You can get even more minimal when just pulling. For instance, a Docker pull needs 3 ECR actions, and that's it. So think about how your audiences are going to use the push and the pull action, and that gives you some insight. Second best practice, what is your repository strategy? Think about repositories differently based on your application stage, right? This is typically driven by a deployment of your application pipeline. So, for instance, most of us have developer builds pushing images. Some subset of those make their way into staging, and an even smaller subset make their way into production. So, as you go further down the pipeline, think about tightening your controls so that blast radius of an inadvertent action is lessened. For instance, deleting a repo as a dev versus at a stage versus in production has a whole different level, right? And with ECR and IAM, you can easily control what you can do. The third best policy I want to call out is resource policies. Did you know that ECR has resource policies as well as policies on IAM principles? This is very useful as a rate of change concept. For instance, if you have a lot of repositories that come and go, you create and delete them a lot, it becomes easier to create a default resource policy and attach it to a repo through CloudFormation or Terraform, instead of scanning through all your IAM policies and then adding in new resources as your repository arms keep coming and going. And that's simpler than doing this, and then, heck, that's even better, I think, than just having resource star in your policies, which I think we all know we probably should do. I thought to share some insight, maybe, into how ECR itself uses the registry. Ourselves. It starts with our repo and our pipeline strategy, and then we apply access controls over it. So, for instance, we segment stages using accounts. Beta, gamma, and prod are our typical stages, and we have a different AWS account for each, and we have a different AWS account for each in each region. So we segment by account, right? Inside each stage, there is its own repository, or a set of repositories. And controls tighten as we go from beta to prod, right? So, as an example, our scanning microservice, right, the image scanning microservice, when we operate it, there are a few containers that get deployed together, but we also deploy the vulnerability definitions as a sidecar container. And as those definitions are refreshed almost daily, which is at a cadence very different from our code changes, we can apply push controls differently, we can have ownership differently, and we can track and audit changes differently. So another thing we do is we use tag immutability by default. It's just a best practice for us. So I would encourage that you think about tag immutability on your repositories, definitely at least for your production ones, because this helps you pin your software to a specific version. So you always know exactly what you're running in production, right? I think that I wanted to leave you with, how do you think about access? And how would you, like, when was the last time you reviewed your IAM or your access policies for your repositories, right? This will vary, of course, by organization, by structure, right? The best practice is to manage access to your resources separately for push and pull, right? But how you do it, whether it's by image tag, whether it's by different repositories per stage, or different accounts, that's going to vary, right? So how you implement these practices and how you apply them to your organization may differ a little bit, but the fact that these are some of the things I would encourage you to apply are common and consistent across all. Okay, now we spoke about access controls. Let's talk about the second piece, which is image assurance. I'd like to start with an image workflow when talking about image assurance. So a developer writes code as they build their application, creates a Docker file that puts the application dependencies, all the software needed to run that application, and their code themselves into an artifact. This creates a reproducible package that can be distributed across your various stages of your application lifecycle, which gives you a consistent developer experience, right? The value proposition of running container workloads. After tests and a build, you can see that that image gets pushed into a registry, whether self-managed or self-hosted or managed like ECR. From here, a container can be run from that image. This can be using an orchestrator, ECS or EKS, or even on a developer's laptop if they want to pull the latest image and test it. While talking about Docker images and running containers, I want to think about a defense in depth strategy. First is scanning of the static images that are stored in the registry. Static scanning is performed in environments prior to deployments. Right? This enables teams to detect vulnerabilities before the image ever makes its way into production, right? Letting you catch things before they go live. Right? We scan for ECR scans for operating system vulnerabilities and CVEs, and so this lets you not worry about setting up your own scanning infrastructure, to not worry about paying third-party licenses. Right? The second aspect is dynamic scanning or runtime protection, and this executes in a runtime environment, so you can identify vulnerabilities during QA, in production, and 0-day that occur after you've deployed. Right? ECR today does not offer this capability, And we have excellent security partners such as Aqua, Trend Micro, Stake, Snake, Black Duck, Binary Analysis, that our customers use with comfort. So those are excellent choices for you to make when it comes to things like this. Let me talk about image scanning and what we offer in that aspect for you. So image scanning, as I spoke about before, is static scanning of container images, right? We use the common vulnerabilities and exposure database from the open source CoreOS Claire project, which we operate in the cloud. We use the severity from the CVE. We use the severity of the CVE from the upstream source where the feed was, or otherwise we fall back to the CVSS, which is the common vulnerability scoring system. That lets you be able to use the National Vulnerability Database to determine the severity rating from that score, right? With ECR, you can review scan findings for information about your security, about the security of your container images. You can see them in the console, you can see them at the command line, and I'll show you some screenshots later. There are two ways you enable scans with ECR. Manually scan them or ad hoc through an API, or image scan on push when you push an image into your repository. ECR issues an event when a scan completes, and you use that event to derive actionable insights into your security of your container images, right? We fire an event to Amazon Event Bridge, and so you go from there. Lastly, scanning is no additional charge. So if you're an ECR customer and you push your images into us, we'll scan them for you. Let's look at some example findings from ECR image scanning. First, find the repository you want to review. You can see scan status and high-level results, and you can click on the vulnerabilities for details. You'll see this nice graphical representation of critical to informational findings. A critical high being the red-orange is still likely to be what you need to take on. You need to take action on right away. Also, you can search for findings, sort by severity, review the description, and there's a link to the external CVE for your review. ECR stores only the last image scan finding at this time. One thing to note is that we have a pending ask and something on our roadmap to be able to push our scan findings into Security Hub for some of us customers who use both services, and that is something you will see on our public GitHub roadmap as well. I've also shown you some examples of scan findings at the command line, which you can use when you're building automated tooling. Now that we've examined ECR image scanning, let's look at some best practices. Here's the first. Turn on scan on push. It's there for you, it's no additional charge. We're testing CloudFormation support for it to turn that on as we speak, and you can use Terraform with it if you're a Terraform customer. Right? We're also building account level settings in ECR, so you can make this enabled by default for any repository that has been subsequently created, whether through your infrastructure as code scripts or not, right? I've linked to both the GitHub public issues that's tracking this work, so you can see how we progress along that. Second best practice, don't just scan on push, parse the event. ECR issues an event bridge event for every image scanned, right? You should parse it at minimum for critical and high severities, and you should take action for your staging and your production images. There are two links in this callout. One, how to set up a filter for this event and trigger Lambda, and the second to a GitHub project with sample code that comes from a scanning webinar we did last month. And the sample code shows you how to stop a pipeline from deploying if once you push an image into that repository, if a critical or a high was formed. This lets you, so take a listen to this webinar, right? The webinar link is in the GitHub that's here. And think hard about how you're going to parse for the scan completed event, filter for your critical vulnerabilities and your high vulnerabilities, and then take action for, at minimum, your production repositories. And the third one I'd like to talk about is rescanning or scanning out of schedule, right? Images that you deploy from your production repos should be rescanned at least once a week. We are being asked to do this natively in ECR, and please +1 the linked issue to it if you like this idea. But in the meantime, when you can, read the linked blog and use the sample code to set up a Lambda function that triggers an ad hoc scan from a scheduled CloudWatch event. Right? This is an easy way to stay vigilant for vulnerabilities that are found after you've already deployed. Right? And if you're already processing the scan complete event, you'll be able to take action if something is found. For example, sending an email to SecOps. Or another action you can actually take is to apply a deny pull resource policy on your repositories if a critical RI was found. And then when that's resolved and a new image is pushed, remove that policy. And that becomes a really nice way to be able to take your resource policy best practice from our previous discussion on access control and tie it in with scan on push, parsing for a critical vulnerability, and then taking action if it was a vulnerability from a production repository, for instance. Right, for our final piece around container security at the registry, I'm going to talk about artifact trust. Right? Artifact trust is image signing along with policies to control actions based on signatures. The 5 categories you see in front of you are what our customers, you, are telling us what modern container artifact trust needs to be. It needs to be native to a registry. So an image and its signature is co-located for security instead of being in separate services. It needs to be usable for easy integration into your CI/CD workflows. It needs to be portable. Images are often used as base layers. They journey from a publisher that may sign it to a public registry that may sign it as well, and then pulled into a private registry used as a base layer, which is then signed. So these signatures all need to remain valid so you can track provenance. Right? Signatures, secure concepts on signatures, such as no trust on first use, secure private keys, and PKI is needed for modern artifact trust. And finally, solution has to be multi-tenant, so that large enterprises as well as cloud providers can run this easily at scale. And because of what we understand is what we need to do, and because we don't really see an open community way to do that at this moment, AWS is helping drive the creation of a Notary v2 standard. So Notary is a CNCF project created by Docker, and we're working hard to create a version 2 with the broader container community. You should be able to see, you should see a few logos over there, which are collaborators at various times. This is by no means exhaustive in terms of the list. And these are just some of our more consistent collaborators at the current time. Right. I thought to share maybe some of the timelines on this so you have some understanding of where we are. Right? How it got started. It started at KubeCon last year, 2019. When AWS, Azure, and Docker discussed the current state of image signing. Right? A link to the subsequent talk given by Justin Cormack at Docker is here. AWS then hosted a kickoff meeting in Seattle, which was attended by most major registries. Right? I've linked the kickoff meeting notes if you want to see. It's open and public. The group meets every week on a Slack bridge. It's a CNCF project, so you can get, I think we record as well, but I'd have to double check. And this is open for anyone to join in, to listen, and to contribute. Right? And what's next? Next month at KubeCon, which is the virtual-only version of the Amsterdam KubeCon, we plan to give an update to the community on status. Right? Links to both Notary sessions are on the agenda. Right? We plan to have a rough code solution by the end of Q3, something that shows how a draft Notary v2 client and a registry can collaborate to create a signature. By KubeCon in Boston, at the end of this year, we aim to show demos and open it up for community use. Right? AWS itself has a committed plan for ECR and all container orchestrators, ECS, EKS, using both the EC2 and Fargate compute types to be able to deliver a GA solution to our customers in 2021. I've linked the GitHub issue that we're using to track this effort, and I'd encourage you to +1 it, follow it, and see where we are, and see how we track along to that. Okay, so to wrap up, various links to documentation, blogs, and GitHub issues that we've talked about in previous pages are linked to here, and you should be able to have a look at them. And one final thing I'd like to call out is that each AWS container service shares its public roadmap on GitHub, right? So like ECR, so does ECS, EKS, and AppMesh, and Fargate. Please follow it, comment, +1, add issues. We watch, we respond, we groom it. And this way you'll see issues make its way onto the roadmap, grow through the pipeline. Okay, that's generally what I wanted to share. In summary, before we're done, let's do a quick recap. ECR security is part of overall container security solution, right? And at the registry, consider the best practices around who can push and who can pull what resources, and that's access control, right? How do you check for image vulnerabilities before you deploy and after you deploy by understanding which your images are running and rescanning for them? And think about artifact trust, provenance, freshness, immutability. Read up and stay connected on Notary v2 as we work to get that into your hands in 2021. Thank you for being ECR customers. We really love that you use our service, and customer obsession for us is number one. So by all means, you know how to reach us, and we're there. And if you're considering using us, just wanted to learn more, I hope this has been a good use of your time. Thanks for watching.